So in this video, we're going to start the actual Fasetto Word server application. So the actual website that'll, handle everything for our main programs. So in the last video, we did I just jumped to it, the Entity Framework Basics. So we're pretty much going to clone this repository, rename it, and then use that as our base. So I'll literally copy this from the YouTube repository. Chuck it into the Fasetto Word. We've got the source. Now we've got Fasetto Word core. So we can chuck it in here. This will be fasetto.word.server, or we can do fasetto.word.web.server. And then in there, we copy that name. We can delete all the temporary files. And we'll just literally open these first to make sure there's nothing residual in there that we want to change. So we've got Entity Framework. We'll change this to Fasetto-Word. We'll log in for now as just ourselves. That can change in the future, like as the Windows account. Pretty sure that's fine as is. Yep. We'll rename the project to the same thing. The solution will move up to the top level. Rename this to that. We'll edit the solution with Visual Studio Code, and then it will be in this folder and that project name. Then there's the default namespace I believe it picks up from. So that should be all we need for the cloning of this, I believe. Everything else we can do once we open the project. So let's just open this solution now, and it should, close that one down, it should open Visual Studio, and we have basically the place we left off at the last video, but with fasetto.web.server as the namespace and project name ready to start padding out this application. So I'll just right click and go Properties here. So you see the default namespace was picked up by that change. We've got .NET 2.0, which is what we want. The build is all standard, that's fine. All that's okay. Profile test is just the name of the profile we gave it in the launch settings. So we could call this Kestrel. I just like to be explicit on what it is. And we'll go port 5000, that's fine. So that's all the settings okay. The root's got nothing in. The controller is a base home controller. We'll quickly change, for one, that bit was wrong there. We'll change anywhere we find that with the new namespace, fasetto.word.web.server, I believe it was. And just replace all the namespaces. And then we could do a quick search for Entity Framework Basics to see if there's anywhere that's still in there. No, so that should be all the namespaces updated. We have the context, the constructor, the sample bit here, which we can leave in for the moment till we get a feet grounded with Entity Framework. Control RG to remove any unused namespaces, keep things clean. That can stay there. IOC container, it's fine. And the IOC container is on the service provider, that's it. Homepage is fine. App settings, we've looked at, that's fine for now. Programs done. And startup. So, we've got a clean application. Let's now just make sure this runs first. It should also create a database. So we open SQL Management Studio, and we'll connect to this machine. And when this spins up and we hit the home page, we should see. Let's go get rid of test. That was, yeah, that shouldn't be the name of a database. I think that was the old one. Entity Framework would have been the old one. So now it's spun up. It should be creating the database. So when we finish, press F5 on there, and you can see now we have Fasetto.word, so we know we've got that database and we've got the settings. So that's good for now. We've got that. So all we've really done there is cloned the last project, but we've cleaned it all up and named it what we want. Now, before I forget again, let me just turn the present on to make this font bigger for you guys. There we go. So the first step to basically getting users added to this website so that you can sign up, if you will, create users, manage users. Luckily, this is something where we can use the built-in ASP.NET Core services, if you will. So they handle all of the HTTP context, the cookies in the web browser. They give you the ability to hash passwords, verify them, lock accounts, two-factor authentication. It's all done, but it's all open source, so you can see. Also recommend when we're doing something like this and making use of an existing thing, even when it is .NET Core itself, so it's been done by Microsoft and their code is one of the cleanest of any people, to still understand at least what you're doing. So don't just go and dump commands in and not understand, because it does quite a bit. Now, it's a lot of code that we don't need to do because they have done it, good while, and it's maintained and open source, so any issues get found. But as we step through this, I'll basically break it down and show you the source code of what's happening. So we understand what the DB context does now, that it's basically like a database, and then each of these DB sets is like a table, and then the models inside the sets are like the columns, and the information about the tables, the rows and the types and things. So in order to add, and typically you'd also try and keep one database context for your application, because that's like the database. So you don't want two databases for most applications. So the first step to start including the what's called identity, which is the thing that handles users, is to tweak this DB context. So from a standard DB context into an identity DB context. And we'll have to stop the web server to be able to type that. So it's an identity DB context, control dot to bring up the IntelliSense and include the namespace. And then it needs to know the type, you see, of user. Obviously, the user is a row in the database, and it needs to know information because everybody's application is different. Users might have emails and locations or specific things to your application. For now, we have just our basic user. So again, we'll split this up as it grows into correct projects and things. For now, I'll just chuck this in the data, and then we'll organize this project as it grows. So in here, we'll just do a class, and we'll just call this application user. Get rid of the extra namespace, get rid of all that. And then this it will inherit an identity user. Control dot and include the namespace. The user profile for our application. The user data, and profile. So all we're doing is literally making an instance, if you will, inheriting from identity user. We're doing nothing special right now. We could do by simply adding information in here, but this just gives us the ability in future to actually expand upon identity user. So this is our custom class, and that is the type of user in this identity, and that's the identity of this context now. So now this identity context will give the ability to add ASP.NET roles, users, all information about that it needs to manage, sign-in data, two-factor authentication. It's all baked into this now. By doing this and telling it this is the type of user, it will create a bunch of DB sets for us, which I don't know if you can just see by F12ing in. Identity DB context. That goes out even further in. And then you can see here now, it will create these, because the DB sets, you'll now have a database table with user roles claims, and they've got some attributes here that configure these with specific table names, so they won't come out exactly as that name. They'll come out something like ASP.NET user roles, but here you can see they're basically adding database tables for that, and then the rest of all this gubbins in the DB context adds the ability to manage that and do that, and again, it's something we don't have to actually make. So by doing the identity DB context, we're adding those database tables. So we do that step. In theory, if we build this, delete this database, and presuming this builds successfully, which I'm pretty sure it should, or it already has maybe, I'll just run the application. And then when this spins up, it should create the data. Well, it will create the database still, and we should see those new rows, even though there's nothing in. The database will have to be initialized with those. And I'll probably turn this onto that so it's not as harsh on the eyes. Right, so that's now created. If we refresh the databases and we go in this time, you can see here all the roles I was mentioning, all the database tables. And you can go ahead and inspect them. This is now what the identity has created for us. So this is like the users is the part of our application user we made, and these are all the defaults: normalized emails, usernames, the email and username itself, confirmation, two-factor authentication, phone number. These are all baked in as like kind of defaults. Roles are when you start giving users specific permissions or like grouping them. Some people might be admins, others might be developers. The roles is good for that. These are all the logins, so they're kept in the database based on, you know, where they're coming from, which login provider. So our own application or two-factor authentication from Google, things like that. Claims we won't go into right now. It's basically similar to roles in terms of, you know, what you need them for. It's all about grouping the users together. And then user tokens we have as well. So we'll start making use of these, but you can see straight away the implication of changing it to identity DB context sets up the database with identity, sets it up with something ready for the built-in identity services we're going to be using to make use of. It needs to be an identity DB context to have those correct tables. So we've done that little step. So now we want to start configuring and using this. So we jump back into our main code here. We have the DB context already, which adds the application DB context as a basic, you know, as a context itself. Nothing special about that. We still leave that in there. And it configures as a use SQL. So in addition to that, part of the identity setup and process, as I mentioned, is once you're on the website and you log in, you need the ability to, when you refresh the page, not have to log in again. So part of what we do, or part of what ASP.NET does for us, is handle, you know, when a user logs in, creating a website cookie and keeping that cookie alive for a set period of time. And that will contain a special key that will appear in the database as a login. So if we were to now do services.add identity, and then again it's expecting a type of identity. So that identity will be the application user, and the role, we don't have any specific role. I'm not getting IntelliSense at the minute. Why not? I just want to show you guys the IntelliSense. Let me just try and identity role. See if that'll stop complaining now. So see if we get IntelliSense back. So similar to, there we go. Similar to the user also has to have roles, even though we don't have any roles. So we could create now a specific roles and then, you know, implement certain ones, but we're using the default identity role because we're not making use of it. So we're telling this code to add identity, which you'll see what it does in a minute, under this application user type, because that's the one we're using here, and just the default identity role baked into the framework. So we'll make notes of all this. So add identity adds cookies, as I mentioned, or adds cookie-based authentication. It also does, and then I'll give you a link to this so you can see. It adds scoped classes for things like user manager, which we'll use to create users, delete users, you know, literally manage users. There'll be a sign-in manager, which, as you expect, would be for signing in. There'll be things like password hashes to generate hashes of passwords to then verify, and so on. So we'll make that note there about that fact. We'll also then provide a link, and we'll go and look at this now in source code. One more note on this actually is that basically once you sign in as a cookie, whenever you refresh a web page, cookies based on that website are always sent with the request by the browser. So that's just the natural way websites work. If there's a cookie, which is just a text file on the the user's machine, storing information that the browser can create. When you sign into a site, it will create that cookie, which is, like I say, it's just a text file, just got some info in, and it just gets served as part of it, almost like a header, if you will, to the web request. It comes in as an actual cookie, so information can be passed back and forward automatically. So that cookie basically gets read by this setup here, the add identity. It will then automatically read the cookie from every request when it comes in before it hits our controllers. So before you ever get to, say, this page, there's things that go on before you ever build up to a controller action. And one of those from doing this is something that then reads the cookie, decrypts it, sees if that key is in the ASP.NET logins list to basically see if we have a valid login already. And if it is, then it will automatically adds the validated user from a cookie to the HTTP context.user, which will access in like a controller here. So you could say context user and then identity, and then you've got access to now at least your username from the identity, that then you can use the user manager to get information from that. So this automatically adds that, once you've signed in and you come back in your controllers, this would always be already pre-filled with a pre-validated user that does all the work for you. So you can literally just check HTTP context.user for that information. So we will give a link to that. So if we go to this first page, this is just the source code of ASP.NET identity, and then in identity service collection extensions. And in here, we should see add identity, which just calls the inner one. And if you keep scrolling down, you'll get to like line 59 here. Where you see this is effectively here is what it does. So this is the whole thing. And if we take a look at what this is actually doing, one, it's adding authentication because there's multiple ways your website can authenticate. And all it's doing here for us is adding all the default ones, if you will. I'll say default, it's adding cookie authentication, a security stamp validator, which we'll talk about near the end of the video, setting up the path to redirect to when people aren't authorized, which we can also override, and we will do. Setting the time that the cookie expires, so how long the user has to sit on this page without refreshing the page before they get signed out, which again we'll play with to show you what's happening. And then it adds two-factor authentication scheme for the same, it basically sets it up ready for two-factor authentication, even though we don't make use of it just yet, but we will. So that's all just one call, if you will. That entire thing is setting up authentication, and authentication to use the built-in identity setup, which, as we mentioned, basically uses cookies and a security stamp, and then it's ready to use two-factor authentication. So all that will be, you'll see that as we use it, and it'll make sense. Then this is just all gubbins. Well, I say this, just this one here really, is just the ability to make use of this interface, which is needed inside of the way that this identity works. It pulls in the HTTP context from within areas you wouldn't usually be able to get to it. So this lets you do that. Well, not us, but it lets the inner service, the identity service in ASP.NET Core to use it. And then it adds all these scoped things that you'll see and you'll be able to pull in. So all these are in the scope of a web request. So every request gets them. And you can see you've got user validator, password validator, hash, lookup normalizer, role value, all these you can see. The main ones we'll make use of right now are like the user manager, sign-in manager, roles manager, maybe the validator. We'll use them all, but you'll see really all that call is doing for the bulk of it is this. You add an authentication, and then they add all these providers so we can make use of them in our actions nice and easy. And they're using, again, these are baked in pre-existing managers that you can make, and I did actually end up making my own when ASP.NET 1 was out because it wasn't quite good enough, and it was a huge amount of work. So now these are luckily good enough and stable that we can simply make use of them, and then that just returns. So that's it. That's all it does. And you can also, you'll notice you'll be able to run a configure command or an action if you pass it in, and it simply does services.configure and passes in just the action that you pass into here to get the option. So if you wanted to configure them at the same time, you can do it in an override. So that link we'll put in the source code there, and that gets us to step 1. And then if we now we've done the add identity. The next step is to do what is the next step? Add entity framework stores. And then you can see it's asking for context. So that is obviously application, say obviously, it does to me, but application DB context. And then this method, so let's close that off there. This one, again, right, so let me think to explain this correctly. We will have, which is quite simple to be honest, it does what it says. So it adds, I believe, the user store and role store. I think are the only two from this context. And again, we've got the source code open so we can double check this. But these two you haven't seen in the last, you didn't see them here directly. But the user store and the role store are, again, helper classes that will wrap the correct database tables. So it'll wrap the users, the roles there, it'll wrap all these into a class and then make them accessible for the sign-in manager, the user manager, the role manager. So even these add the user managers here, but the user managers are expecting a user store and a role store of where to find those users. So this bit adds those stores to tell them to come from, obviously, Entity Framework. So if we take a look at that source code, we should find that extension method in here. So there's the add framework stores that we've just done. You can see again this bubbles down, and this looks a bit complicated because this is all kind of generic stuff that just does look messy and confusing. But if you simply scroll through and look at this, you can kind of gather that it's basically trying to find existing info from it. So it's trying to get an identity DB context, which we are, so that'll be given. And then if it equals null, which it won't be, to just make generic user stores for us. Otherwise, it'll try and get the user store based on the types and bubble down to ultimately simply calling these two functions. So you don't need to really understand all of this generic stuff and what's going on, because again, this is used internally. You just simply need to understand at least the principle of what's happening. And you can see that in essence, no matter what happens, it always boils down to adding a user store and a role store, or adding a user store, and it's based on the types. So because we've passed in the user and role here, these are the types that it would be. So by calling add entity framework stores, we would then be able to get the services. So if we did, say, in this part, you could do IOC dot, I haven't even exposed provider yet, IOC container dot provider dot get service, and then you could do a iUser store of application user and get the user store that way, and that should be available in the anywhere in the code because it's injected here. And then you can do whatever you wanted with that user store. So you can say var user store, and again, we wouldn't do this because this is handled by the user manager, but it's just showing you what it does. And then you've got the action here to create users, delete users, do all your user functions, but you don't end up using the user store directly. Instead, you use the user manager. So you'd use a user manager of application user, and now the user store, even though it's a manager, has more functions, and it's all built up to handle a lot more. But that's all that's doing. That identity framework stores is adding the user store and the role store from this context that are consumed, can't spell. Consumed, yes, by the user manager and role manager. So that's a nice simple one. And then we'll put this link in so you can see. Just at least that's all it's doing. It looks very generic-y, but all it does is finds baked-in types like this, and if you pass in this and it's an existing one, it uses that instead, and then passes it ultimately in the constructor of a user store and a role store. So we'll pass that in. And I think there's one more step that I always forget. default providers. There we are. So again, another thing that's needed is, in fact, we can put spaces in this to make the comments look a bit nicer. Adds a provider that generates unique keys and hashes for things like forgot password links, phone number verification codes, and so on. So again, as part of all this user manager and password stuff, and anywhere that you generate, like when you forget your password, it generates you a unique key that then usually emails you the key, and you click the forgot password link and you can create a new one. So this little thing here is responsible for making those unique keys in a way that's believed safe and unpredictable. So again, it's a simple thing. You could just do a new GUID for everything. But ASP.NET Core has baked in those providers that then get used by, these user manager and things. So that should be all we need to do. In theory, if we were to remove the comments, all we've done is that. So we've only done 3 things. We've added it. I've clicked run as well. Let me just stop that. We've added the identity. We've added the stores that the identity needs, and we've added tokens the identity needs. So all we've done is added the identity and then added 2 things that it needs. And then we just bulk it out with comments, because obviously comments are good, and then you can go back and read and understand exactly what the implications are of doing all that. So we've got good enough for there. I'll put notes here, or a to-do, so I don't forget, and I'll come back to them. Change login URL, change cookie timeout. So we'll do those 2 things. We'll come back to those 2 things. And then we also mustn't forget in the configure method, which is you add your required services, and then the services need a point at which they set up once all the services have been added. So set up identity, and this is just app.use use authentication. There we go. And basically, there's only ever one authentication call now, no matter what type of authentication you use. So this is the one that's adding the authentication, and it's identity authentication. You only ever have to call this. So if we change the way that we identified users, the sign in the process, you still just do the user authentication, because they should all implement the same thing that then gets called via this call. So that is really, for the most part, everything we need to do to set up and be ready now to do what we want with users, believe it or not. So now we can create users on our website, we can authorize them, we can reject them, we can redirect them, we can send passwords, there's all sorts we can do. And you might not believe it, with it being that simple, in a sense that we've only really made 3 calls and now we can do that. But that's kind of the beauty of using this, using something that exists, but in a way that now we understand enough. And you can always dig into it in source code is the benefit. So I wouldn't just add those 3, start using it and do it blindly. When we do a create user, you can then search GitHub for the source code to that and have a look yourself at what it's doing, so you understand. I'd definitely recommend that. So I won't delve into that in this video because it'll go on too long, but I'd certainly look at all the calls that we make from now on, going into those, and have a look yourself. We'll cover them more in future videos, but it's beneficial. So I guess the first thing we want to do is create a user, so we can see the user being created. So again, we mentioned in the last video, we do constructor injection to naturally pull in a scoped service based on effectively this class. When it's in a constructor, it's scoped into this. Whenever this is created, it's part of that scope. That's how the scope works. So we want now, as we mentioned before, a user manager. So control dot to get the pop-up, if you will. And we have the application user here. And this will be the user manager. Put that on a new line. And we'll also have which we don't use just yet, but we will. Sign in manager of application user, and that is sign in manager. And then we just do protected And we can copy this. Could have just typed it quicker than copying, but never mind. And this will be M user manager protected sign-in manager. And this is the manager for handling users. Quite simple. Manager for handling signing in and out for our users. User, I guess, creation. Other creation, deletion. What else do we do with the user manager? Creation, deletion, roles, searching. Okay, yeah. So there's our protected members that will inject through the services, which will automatically get filled here, just like the other one did. And then we'll set them up to be the user manager and the sign-in manager. And then we can just double check that that works. So if we spun up the application now, we should find that these get injected. And the reason they get injected is because, as we saw in the source code, the add identity injects a user manager. So as this spins up, the user manager is now the ASP.NET user manager. And the sign-in manager, as you'd expect, is sign-in manager. So we have them injected. So now we're ready to do what we want with the users. And as I mentioned, they have been injected due to the fact that the add identity adds the scope classes, as we saw in this link. I can now close that as well. So we have that ready. We've injected into there. So it's now time to actually do something. So let's go here, do a public task of, because we'll have to await the creation of a user, iAction result, which is any kind of result. Just call it create user async. So just a normal call. If we do root, so it can be found, and we do root create, and again, we'll move this into a core. We'll add the Fasetto Word core, and these roots will be embedded in there, so we know where to call them from. For now, we'll just return content user was created, we'll just say. And we'll have text HTML as the type. And because it's a task at the minute, we'll just do task.fromResult. And new content. Okay, let's just do return content, and for now, because we're not awaiting, in fact, let's just do a little trick. Await task.delays. Await. Oh yeah. Async. Await task.delay 0. I'll just do that so we don't have to do anything here. So all we'll do for now is check that this create route is plugged in. You can simply type in localhost/create and we hit here. And then we should just return text that says the user was created. So that's just making sure our general MVC routing is working. So hello world/create. You see we hit there, we return, and it says user was created. So we know at least now we're hitting that function. So in here, let's just create a user. And obviously you wouldn't just create a user like we're going to do here. You'd actually have a sign up form to your website, which we will do. But again, for now, I just want to show it actually doing the work. So we'll do successful, which is the result. And it's awaiting the user manager we have. And it couldn't be any simpler, really. You create a user. You pass in the type of user, which is our class that we already made. And you can do username, we'll have as Angel6. Email, we'll have as my email. That's all we need. Then we could say if successful.succeeded. So really that's not successful, that's result. So we get a result from this call. If it succeeded, we'll return the user was created. Otherwise, we'll return that user creation failed, which it should do if we run it a second time, because it should automatically detect that the user wasn't there. The one other thing we obviously need is the password, which you don't pass into the into this class, because you should never have passwords in memory objects. They should never hit the memory. They should always be passed through parameters down to the point where they're used and then hashed. So that's why you see the password passed as a secondary thing. And here we'll just say password, and then we'll break here and we'll run this and we'll see what happens. So that's the normal part spun up. We refresh this create. You can see we've run it. It's run fast. We have a result, and you can see we've got errors. We've got 3 errors. One is password requires non-alphanumeric. Password requires digit. Password requires uppercase. So you might be saying, well, where have all these come from? How are we getting password validation things going on? The answer to that is quite simple. In fact, we should have ran that fully and made sure that that shows password user creation failed. Just to, check that your failure also works, not just that. So there you go. User creation failed. We don't bother saying why. Couldn't care for this demo. It's in the results. You could output them. I'm not going to. So where did that password validation come from? Well, as you noticed here, I started mentioning you do all this lot. So if you open this link that we had open and you search for password validator, look what we get. We get a default password validator. So if we were to then search the source code for password validator, and you could bubble down to trying to find it in here. This might be the right one. And you can look at what it does by default. So this is the default validator. This is the bog standard off-the-shelf password validator that gets added. You can see here is where it doesn't have them. If not, it adds the errors. So by default, we have these options, and the options are coming from the manager options. So all we need to do is replace the default options with our own. So to do that, you can do it directly in the add entity, as we saw in that override. We have this options here that we can specify, but I like to keep this bit all done in one place. So let us change here, change password policy. And obviously we'll revoke these in the future ones, but for do that you do services.configure, standard configure, and we want to do identity options. And then we'll be given the options, and we can go ahead and change them. So make really weak passwords possible for now. And we do options.password.required digit is false. Options.password.required length, let's say 5. And by the way, never ever do this in production. This is obviously just to show you what's possible. Require lowercase, will at least require lowercase, will require some text at least. Require uppercase, will remove. And finally, we'll remove the requirement for alphanumeric, as in something other than a letter and a number. So that'll make it stupidly insecure. But now if we run this code and run create, we should actually be able to create that user. So if we refresh this page, user was created. Oh, good. So we didn't breakpoint into that, but really the only other option was if it was successful. It just tells us that anyway. So what that should mean now is in our users table, right click and select top 1000, we should actually see that user. And we do. I don't know what this null thing is. It's interesting. I also am not sure, that view seems a bit weird. Let's just make a new query. Do it ourselves. Select all from ASP.NET users. There we go. That was just a weird view. I'm not sure why select top 100 shows like a... Oh, maybe I clicked the wrong thing the last time, so it works that time. So you can see here we have the ID, which has been generated by that token provider potentially. If not, then it's simply part of the identity that we always use GUIDs for the IDs. We've never failed an access. We've got a concurrency stamp, which is used by the database. If 2 people or 2 calls or 2 threads try to edit the user at the same time, before they edit the user, they pull the concurrency stamp. Then they do an edit, then they try and commit. Every time a commit happens, this concurrency stamp changes. So at the point of commit, it's a standard database thing you can look up on Google, and it's called concurrency, database concurrency checking. So basically, it just simply ensures that this line of the database can't be edited by two things at once by use of a concurrency stamp. So it can figure out, who was first to try and commit. The email is what we were given. It's not been confirmed by default. Lockout's enabled by default, so if they try multiple times, we can lock the user out, and there's all policies there. Failed login 5 times, lock them out for 5 minutes, that type of behavior. That's baked into the ASP.NET identity that we're using. Normalized email is simply, as it states, it takes our email and normalizes it. So if we want to do comparisons, we want to find a user based on email, and we type in contact at, like this, uppercase, lowercase stuff. Then trying to do a search for that in an SQL query for this email wouldn't work. So instead of having to cast our code to certain states, uppercase, lowercase, and do comparisons, for quickness, at the time of editing the email, it creates a normalized, which is just uppercased version of our email, so that when we try to find a user by that email, we can simply compare it via uppercase, and we know that we should find it. Same for the username. The password is a hash of the password we entered, which was just password. The phone number isn't entered or confirmed. Two-factor authentication is enabled. The username's there. And then the security stamp. So I was going to talk about this at the end, but we might as well talk about this a little bit now. So this security stamp basically changes every time anything related to the security of this account changes. So if your username changes, the stamp will change. Your email changes, the stamp will change. The linked two-factor authentication, anything that is revolved around a successful login, anything that would change the details of a successful login, then the security stamp changes. Now, what happens when you log into the website, as you'll see, is you then get a cookie, which stores a unique ID of your successful login. And that cookie will last however long it should last, which by default is 30 minutes. So every 30 minutes, the cookie will disappear and it will naturally re-authenticate. Or even if you are stayed in, this security stamp will always be checked for authenticity every time. So every time you get a login, it will be checked. And again, there's a default timeout on when the security stamp will be refreshed, which we can change. And if this changes, it will just simply invalidate any logged in user. So if we were to say update our email address in our code, and we say update email address, we should then forcefully tell ASP.NET to update the security stamp as well. But by default, this will update automatically once every 30 minutes. But if we ever want to force that action to instantly refresh it, we can call update security stamp. So that enables things like, say you have multiple apps signed into your application, and they get given a unique key. That's why when you log into something on your phone, you don't have to keep logging in again. It simply knows it's on your phone, and that's due to a key. But then say you go and edit your username online, you want your users to be kicked out from the phones to re-authenticate to make sure, it's still a valid user. So that's what the security stamp does. We'll see that in action. I'll probably do that in a separate video, just so we can, spend a little bit of time looking at it. But that's what the security stamp does. And like I say, we could mess with that, but I think that's enough for now. So we've now created the user, and it's created the user in the database. So now if we were to, and we can also look at the error here. If we were to then try to create the same user again with the same details, we should get another error. And there you go, we get the duplicate username, which is again built into the settings. That doesn't allow that for obvious reasons, because that is the key. So we're not going to mess with that. But you can see there we could easily dump out the error messages to the user and handle them specifically. So we know that's now working. We have the ability to create a user, which you would naturally just link up to your login form, or rather your sign-up form, and then you could inspect the result.errors to output specific errors to users. But for now, we'll do that. So we'll just say creates our single user for now. So then you might say, what's the one, how do we sign in? And two, what's the use of signing in if you can't restrict access in the first place? So to make something private is as simple as making a public, whatever you want to make, your normal action, wherever you're going on your website. We'll just call this private. And we will return content This is a private area. Welcome. And then presumably, well, no, definitely, they can only ever get to here if they're signed in, which means we should have access to what we mentioned before, the http context.user. So we can then use your identity and .name and at least pull out the name. Let's make that text HTML. And then we return that. So now to make this whole thing private, you can use authorize. Control dot to include the right tag. And now this private thing, if we also do a root, so it's easier to access, and we just say private, this can now only be accessed by authorized personnel, by logged in users, and specifically by, the roles, if you will. So if you override, then you can specify, specific policies and things. And as you'll notice here, the specific roles. So you can also lock down not only just by simply authority, but specific authority as well. You can do it per action, or you could do it on the whole controller. So every action inside that controller is naturally authorized. So if I just, again, start without that info, testing we can access the private page, and this will actually crash with, I presume this will crash because identity or user is going to be null. And that's perfectly valid to leave like that because they shouldn't be able to access that page without being private. So this will, so in fact it hasn't bothered crashing, which is interesting. I would have thought that would have crashed. So what do we get? Identity, user is there, identity is there, and it's simply null. Okay, so by default it creates all these things. It's simply nulled out. So that's something to bear in mind as well if you're checking that. So that will quite happily now proceed, and we're not logged in, and it's saying welcome nobody effectively. So then what happens if we now lock this area out and run? So now what should happen is the identity service that we set up in here should figure out that user is not allowed, and it should then redirect us to the login page, which again, if we open this link just to quickly show you that link comes from here, where we do the add cookie for the application schema, and the account login is where we expect to go. So this login path means when they are unauthorized, where do you send them? And it sends them to /account/login. So if we now hit up this private, you can then see that's exactly what it's done. It's redirected us to account login, and it's also passed in a query URL saying where they come from. And %2f is just URL encoding for /. So we effectively come from /private. So that's where we should, in theory, in our action, redirect to there. So we can then handle that. For one, I don't like account login, so let's just change that here in our little to-do. So change login URL. And to change the login URL, again, it's services, but this time you don't do configure by default. You have a special one specific for configure application cookie. So we'll do options again. And then here we've got options.login path. And again, this hard-coded bit here, I wouldn't be doing. This would come from a core class. So anywhere we're doing routes to certain places in the code, like this hard-coded, we won't do that in future. This is just for this video. Nor would we do it here. These would all be coming directly from actual routes in a class, so that our entire application and all of our Windows and iPhone and Android apps can all make use of that exact same bunch of expected URLs. So for now, we'll just change it to redirect to /login. And if we run that, we should get the login page, redirecting to login. So let's also make a login part here. So we know now this is a private area that works, that now is redirecting. So we can't get to this area anymore without logging in. So now let's do a public async task action result, login. And we can also make use of, if I remember what it was, if I haven't closed it, this return URL. So if we just pass in string return URL, and it shouldn't be case sensitive, and that should then be given by effectively it will automatically be pulled out by MVC from the query string. So we should then get this piece of information of where to go to. And then now here, login is where you typically present your login page for the user to type the username and password. Then they click a form to submit that back to the website. Here's my credentials. And then you get to the real call that then does the actual login and redirects. So again, for now, just for simplicity and to show you the code in action, when we hit login, we're just automatically going to sign the user into a specific account with the right username and password. So we will do that with using, again, this time the sign-in manager. So sign-in manager.sign-in. So you could do a sign-in via that, but the typical way to do it, because obviously the user would have provided that, it would be to, password sign-in. So then we have the password sign-in, we have an override. We'll provide the username, Angel6. We'll do the password that we know as password. Persistent means based on the cookies. So once they close the browser out, do you want them to be able to, the cookies to stay created at that point? Or do you want the cookie to be, removed as soon as they close the web page? So typically, like banks and things, you don't ever want them to be retained as soon as you close your site. Others, it would be really annoying if you were browsing, say, Facebook, and you closed it and went back on and you instantly had to relog in. So it all depends on preference. I'm going to say persistent for now because we'll show you that doing that. You can also say lockout fail, lockout on failure, as in it won't instantly lock out. It will actually indicate the amount of tries before it should lock out. So it's a little bit inconsistent with description. That'll add to the count of how many attempts you can sign in before you lock out, which is that database table we saw. So it's this lockout enabled, lockout ended. In fact, no, it looks like it's a direct lockout. So I thought that handled it baked in with access failed account. We could prove that after. We can try that. In fact, we could try that right now as the first attempt. So let's first fail with the wrong password. Let's await that and let's just return content testing, just because I really want to see if this is the behavior, so I'm explaining it correctly. And then obviously the root would be the login. So we can either hit login up directly. That's going to complain that we're not called async due to my coding convention style. So if we run this now and we hit the login page, it should attempt to log in with the wrong password and obviously fail. And then let's see what our database has to say about that. So if we do /login, and now we refresh this, access failed count 1, lockout enabled 1, lockout end. So we don't have a lockout, which is correct. So we hit it again and again. And let's see, we have 3 attempts. Let's just hit this up a dozen times. And then you can see finally, I don't know how many times that was, probably 4 or 5. It's now finally locked us out. And now the lockout ends at 9:53, at 9:35 rather. So you can see that's how I thought it acted. So that's why that's slightly inconsistent, if you will. So even though this is saying lockout on failure, it simply means it adds to the attempted failed logins. And then again, you can change that value in the time and the options if you like. I believe it's just in here, in the main application cookies. So you got the log out, path, return. If not, we can find it. And again, you can just find it fairly easily. Access denied, path. Yes, it isn't in that one, but it's easy enough to find. We can find it in the next video and show you changing the amount of successful logins. So on here, we don't really care. We'll just set that false. We might now have to tweak the database just so we can actually log back in. So update SP.NET users, another thing to never do on live databases, but this is a demo, so we're fine. Update users set lockout end equals null, where, well, in fact, we don't have anything else in the database, so let's update all of them. So now we are magically not locked out. So this time we sign in with the right password and we can get the result. So var result equals sign user in with the valid credentials and auto login page for testing. Oh, I just noticed I didn't even do a correct thing there. Private area, no peeking. The URL to return to. if successfully logged in. Then we can do the same thing, if successful. Then we would do, in fact, we could do that in one line. Return, redirect, and we can pass in the URL. So what we'd actually do is if string dot is null or empty, return URL, question mark, then we'd redirect to action, and we'd do name of the index action, or the home, what do we call it? Yeah, the index action. In fact, you wouldn't typically do that, because it's not necessarily the name, it'd be the root itself. But again, right now we don't have a root, so we'll just do that for now. And that is it. Otherwise, we'd redirect to the given return URL. So what's that complaining about? Type of conditional operator not be determined because there was no implicit conversion between a redirect to action. So we're doing two different results. Okay, so we'll just break that out into an if statement. If string is null or empty, return redirect to action. Otherwise, we return a redirect. We have no return URL. Go to home. Otherwise, go to the return URL. And then we would never hit here. Well, we would if we failed. So at this point, it would be failed to log in, which again we could test. So let's test with the invalid password and run this, and the result should now be that we fail the login, and we just simply say failed login, and you can inspect the results so we can see this in action. So if we do login, the result just says failed, and it gives us no real reason. We simply failed login, and the reason for that is also for security, that simply if you fail to log in, you shouldn't tell them information like the password was wrong, your username was wrong. You should literally just say, you failed for security purposes. What you can do, though, is inspect and check with the sign-in manager or the user manager if the user is locked out, to then at least give them that information so they don't keep trying, that, you've got to wait 5 minutes or something. But that's why you get no real info there. So we should now see failed to log in, which we do. So we correct that password now to password 1, or to password. And then we try to log in now. We should see we're successfully logged in, and we've been redirected to Hello World. So we know we're logged in because we've gone to the home page for one. So now if we went to private, we should be able to log in. Well, we should automatically be logged in. We're private area, welcome Angel 6. So now it knows we're logged in. So let's press F12. We're on the storage tab, which is cookies. And you can see we have here cookies for this web page. You have the name of the cookie, which is ASP.NET Core application, or identity application. You can see we've also got this time of how long this cookie will last, which the browser is responsible for deleting or creating. So you can see it was created just, and it expires in 2 weeks from now. So that's the default behavior, is 14-day cookie expiration, which I think is pretty insane. I would not expect somebody to not log into a website for 2 weeks, and when they come back, it's still valid. And then this value is the value that will bubble down in the website to be in the actual information of that user's login. So if we now look at the ASP.NET user's login, we're not seeing it there because it's a cookie one. So it's done based on cookies. I would have thought, though, let's see if we can find any access in there. No, I am surprised because I believe... Oh no, I wrote my own, that's what I'm thinking of. When I did authentication in the previous one, I actually made a persistent database login. So this cookie is handled in memory of this running website. So I believe if we restart the website, that cookie will get lost because it's in the memory of the actual web server. It's kept in memory to the application. So it doesn't bother writing. It's not persistent to a database, which we'll probably do, well, we'll definitely do later. So if now I tried to go to private, there should, Control-Shift-R, oh no, so this is persisting somewhere. So that's actually interesting. I'll figure that out unless somebody wants to comment in the comments on that, where this is then authenticating in, how this is effectively authenticating. What it might be doing is boiling down. What we should really do is decrypt this this password, this cookie data, or just look at the source code of what this cookie data contains and boil it back to where it's authenticating. What it might be doing is boiling straight back down to this security stamp and validating that way, and it simply matches that security stamp. So let's just test that theory. Let's just mess with it. So update ASP.NET users, which would make sense because they've changed this since I did it in ASP.NET 1. So this is like a fresh project, so things have changed. But this is a good learning curve for myself as well, and a good proving ground of what's really happening. So we'll update security stamp. Set security stamp equals, and then we need a new GUID at least, just so it looks, familiar in some way. And you shouldn't really directly edit, obviously, the database like this. This is just for me. I'm curious to what's happening. So that will be without the curly braces. Let's do that. I know it's lowercase, but I don't really care here. We've only got one user, so let's just update them all and refresh. And now we have a new security stamp that doesn't match. I know I've hacked it directly, so maybe not. So let's at least see how we decrypt this cookie. Okay, so I've just done quite a bit of digging into the cookie stuff to try and find out where it's being stored directly, and it led me down quite a big rabbit hole. So I want to do a video specifically on, if you want to understand where that cookie is stored exactly. I basically went through all the source code on GitHub for the cookie management, and it boils down to a few major places where the cookie authentication that's added in the startup class inside add identity adds a cookie authenticator that then tries to get what's called I think it was a data secure data provider and a time data format, and those effectively do protect and unprotect on the cookie. They can be configured to store on the file system, but my main curiosity was where it's actually stored right now. It definitely isn't stored in, well, I say it's not stored in the database. I can't see it in the database. I do SQL server profiler and it doesn't get any hits, so I'm pretty sure it's not in the database. I also did a file watcher on the C drive just as a quick interest, and there was no activity on the C drive specific to that either. So I would have been thought it was handled by memory, but then I published and run it in memory and closed and killed a fresh new memory, and it definitely is also not handled by memory. So I got so far with the digging, and I think what's happening is it's stored in the file system, but in a protected area with the file system. It's actually calling like a Windows protected storage type thing, so we can't access it or see it directly or monitor for its activity. And that's baked deep within the .NET Core source code. So I got so far down into it and then thought, I've been doing it for probably 40 minutes now, and I'm like, no, we'll do a separate video on exactly where, not necessarily where the cookie is stored, because that's stored in the browser. If we just open this and you can see there's no cookie, we go to login, then we'll have a cookie. So there's no mystery here. I found that this is basically handled by a chunking cookie manager or something that basically takes the claims principle of the user, chunks it up so it's nice and small, and provides that. And then, like I said, this time date format decrypts that information. So there's no mystery as to where this cookie is. It's more about, I want to know on the server side when we see effectively, if we refresh that, or if we go to private, where this is coming from, where this, where are we? Here. So where we're authenticating with the cookie authentication handler. and where it's actually pulling the stored information. Just curiosity, this is. We don't need to do it, but now I'm really curious because, I don't have all the answers there. So we'll do a cookie authentication video separately to really dig into that. For now, I just quickly added a logout to the home controller to show you how to sign out. So if we change that to, say, call it logout so it matches, this is how you log out, just sign out, and this will also remove the cookie. So that's how it's done. But like I say, I want to dig deeper right into the core of this to find out where we are. So probably a good thing to also add to the login is to first sign out any previous sessions. So they go to the login page, it'll sign out any previous. So if we were to then spin that up, and then you can do your own tests, and maybe somebody knows this answer, and they can comment in the video as to primarily, like I say, once a cookie's created on this page, so now we're signed in, where on the server side is that, necessarily being validated against what? Where's that stored credential, if you will, like if we want to now clear it instantly. And you should be able to backtrack it through this call, but like I say, I'd spent 40 minutes digging into code and got right down to knowing that it's stored in the data, like a protected data provider. But then I just got bored of digging, to be honest, with doing such a long video in the first place. So that's one for another day. But again, I'd love to see comments. I'd expect it to be in the database originally, which it wasn't. So that's what started the whole process. But now at least if we do, say, log out, you'll see that that'll now clear the cookie. So we got those pages. So let's just wrap up the few bits left in this video. The cookie that you could see was expiring in 14 days by default. So let's just finish this last to do here. And let's change the cookie timeout. So in fact, that will be in there. Alter application cookie info. And you can actually store the keys to the cookie in here, as the other thing, with data protection provider. So we can, the bit I'm talking about to dig more into, if we specified this explicitly and we overrode a data protection provider, you can potentially just make a new one, but I'm pretty sure we're going to have to set it up. That's a static class, so you can do a create. So we could do data protection provider.create test. And you specify stuff in there, I guess. Might be some overloads. Yeah, there's plenty of overloads of what to do there. So we could create like an in-memory one or one that stores keys on the file system. And that's fine. Then we could see the keys of the cookies being created, and then we'd be able to clear cookies. That's what we'll start in the next video, but the main thing is where the default one ends up going is what I'm mainly after. And I'm pretty sure it's simply on the file system, but just in a location I can't monitor, and I've also hunted for. So again, anyone that knows that, let me know. I'll be curious. To change the cookie timeout, it's simply options.expires time span, and we'll do timespan.from seconds. And let's make our cookie expire every 15 seconds of an activity. Change it to expire in 15 seconds. We can even do 15 seconds. So if we spin that up now, we will have a cookie that should expire if we don't hit the cookie up within 15 seconds. So if we have, I don't think we've got one right now by default, so there's no cookie. So if we then go into login, and we have a cookie now, you can see it's expiring in 15 seconds from the created date. If we refresh, you can see it updates 38. 48. So it's every time we're refreshing the page, it's updating the cookie. If we were to now sit and let that go past 48 seconds, so if we were to watch this go past 48, which it now has, if we were to refresh here now, it should have been expired, so now it's expired basically. So now we went to private, we should hit, otherwise, because we auto log in effect, we should be redirected to login when we hit private now. And you can see we're now at the login. So if we were then to do private again, you can see the private page expires and it hits the private page. So we're not re-authenticating. So the cookie is persisting. You can see there 36 seconds. Now it's updated to 45. And then if we wait for it to go past the 45, that's how the cookie expires. So that's how you naturally get signed out of websites from inactivity. It's this, the cookie expiring. So I think that's covered everything that we were after. Let's just wait for this to time out, go to 53 and then refresh. So now we can just do a refresh. And you can see then we hit the login page, which we then just auto log back in. So that was the starters to effectively creating ASP.NET server application for Fasetto Word. And we've got at least the ability to start logging in users, creating users, and we've done some diving into what's what. The only, like I said, the lack of knowledge right now that we will address is purely about this one key point of once the cookie's been created and that piece of information's there, how ASP.NET is authenticating against that. Like, not necessarily how, we know that it's keeping track of that user's logged in and monitoring the that the user's security token and things haven't changed. But it's more about where is it physically stored on this machine that's running this server. And we haven't got to the bottom of that yet. So that's not super critical because we know the process, we know how to sign them out, sign them in. It's more of a curiosity thing. So that'll do for that video. The next one will either carry on with this, maybe create some actual HTML UI, at least for some basic sign up. So we are actually typing in a username and you can go to register, create a user. And then we might jump back to the Fasetto Word application and have it so that we can create it from that application. Actually call this website, push it live to a server, and start hitting it up to register users, unregister users, all that kind of good stuff. So it should start getting interesting. Any questions or comments again, as usual, let me know and I'll get back to you.